Imagine sitting quietly on your boat when, in just a few seconds, an entire mountainside disappears. Not cracks, not small rocks. An entire section of a mountain breaks loose and crashes into the water. Then something happens that almost sounds impossible. A wall of water shoots into the sky, not 100 feet, not 200, higher than every building on Earth at that time. For a few moments, nature completely rewrites the rules. 3 fishing boats were in that bay that night. 2 of them made it out alive. The third was never seen again. No wreckage, no floating debris, nothing. So what really happened inside those few terrifying minutes? How could one collapsing mountain create the biggest wave ever recorded? And why couldn't scientists explain it with the word tsunami? They had to create a completely new term, mega tsunami. That single word tells you this wasn't just another natural disaster. It was something so extreme that it didn't fit into anything people thought they understood about giant waves. And here's the part that really stays with me. This wasn't ancient history. It happened in 1958. We have eyewitnesses. We have photographs. We have measurements taken by scientists. Even today, you can still fly over the bay and see the scar, the water left behind on the mountainside. The mountain still remembers. The scary part isn't that this happened once. The scary part is that the same conditions still exist today in other places around the world. The right cliff, the right fjord, the right fault line. All it takes is one massive collapse, and history could repeat itself. So this isn't just the story of the biggest wave ever recorded. It's the story of how unbelievably powerful nature can be, and how quickly everything can change when all the pieces fall into place. Let's go back to that summer night in Alaska and see exactly how a peaceful bay turned into the site of the largest wave humanity has ever measured. To understand why this happened, you first have to understand the place. Lituya Bay isn't just another bay on the map. It's hidden along the southern coast of Alaska, surrounded by steep mountains that seem to rise straight out of the water. There are no roads leading there. Even today, the easiest way in is by boat or small aircraft. At first glance, it looks peaceful, quiet, almost untouched. But that's exactly what makes it so deceptive. The bay has a very unusual shape. If you looked at it from above, it would almost look like a giant letter T. A long, narrow channel stretches inland, then splits into 2 smaller inlets. Those inlets are boxed in by cliffs that rise nearly 3,000 feet above the water. Everything about this place traps energy. The water has nowhere to spread out. The mountains leave almost no room to escape. If something big falls into the bay, all that force gets squeezed into a very small space. That's what makes Lituya Bay different from most coastlines. And there's another problem. The entire area sits on the Fairweather Fault, one of the most active fault lines in North America. Earthquakes aren't unusual here. They're part of the landscape. Over thousands of years, those constant shifts weakened the cliffs, creating huge cracks deep inside the rock. From the outside, everything looked solid, but the mountains were already under stress. On the evening of the 9th of July, 1958, none of that seemed to matter. The weather was calm. The wind had settled down. The water was almost perfectly still. It was the kind of evening fishermen hope for after a long day. 3 fishing boats had dropped anchor inside the bay while they waited for the next day's salmon season to begin. For the crews, this was supposed to be a safe place to spend the night. Sheltered from the rough waters of the Gulf of Alaska, Lituya Bay had always seemed like a good place to wait. No one on those boats had any reason to believe they were sitting in one of the most dangerous places on Earth. Within minutes, that peaceful bay would become the site of the largest wave ever recorded in human history. At 10:15 that night, everything changed. Without warning, the ground started shaking. This wasn't a small earthquake. It measured 7.8 on the moment magnitude scale, making it one of the strongest earthquakes ever recorded in North America during the 20th century. The source was the Fairweather Fault, a massive crack in the Earth's crust that runs for hundreds of miles along Alaska's coastline. When it finally slipped, the ground shifted more than 20 feet in a matter of seconds. That's an incredible amount of movement. People across Alaska felt the shaking. Seismographs picked it up across Canada. It was powerful enough to make anyone believe the earthquake itself was the disaster. but it wasn't. What most people didn't know was that the mountains around Lituya Bay had been changing for centuries. The cliffs looked solid from a distance, but deep inside, huge fractures had already formed. Years of earthquakes, freezing winters, melting ice, and constant pressure had slowly weakened the rock. The mountain was already hanging on by a thread. The earthquake was simply the final push. High above Gilbert Inlet, a massive section of granite suddenly gave way. In just a few seconds, nearly 40 million cubic yards of rock broke free from the mountainside. To picture that, imagine an entire piece of a mountain, almost 3,000 feet tall, tearing loose all at once. It didn't crumble slowly. It didn't slide little by little. The whole mass dropped almost straight down. About 90 million tons of rock plunged nearly 3,000 feet before crashing into the narrow inlet at an estimated speed of around 150 miles per hour. The impact released an almost unimaginable amount of energy. For a split second, it was like watching part of a mountain explode into the sea. Anyone who saw it probably thought that was the worst part. It wasn't. Because the falling rock wasn't the real disaster. It was what happened to the water next that changed history forever. The earthquake shook the ground. But the earthquake wasn't what killed people. The moment that mountain hit the water, everything changed. 90 million tons of solid rock slammed into a narrow inlet at nearly 150 miles per hour. It happened so fast that the water had nowhere to go. It couldn't spread out. It couldn't absorb the impact. It had only one direction left: up. For a split second, it wasn't a wave moving across the bay. It was an entire wall of water being forced almost straight into the air. The force drove the water up the opposite mountainside, stripping away everything in its path. Trees that had stood there for nearly 200 years were ripped out by their roots, not broken, not bent, pulled completely out of the ground. When it was over, bare granite was left behind. Scientists later measured the highest point the water reached. The number was almost impossible to believe: 1,720 feet. That's over 500 meters, higher than the Empire State Building, higher than almost every skyscraper standing today. Nothing like it had ever been recorded. And here's what makes this event even more incredible. This wasn't a normal tsunami. When most people hear the word tsunami, they picture an earthquake somewhere out in the ocean, sending huge waves toward the coast. Those waves can be devastating, but they're created in a completely different way. This wasn't that. The earthquake didn't lift the ocean floor. It simply triggered the collapse. The real force came from an entire mountainside crashing into a confined body of water. Instead of the energy spreading across the open ocean, it stayed trapped inside the narrow walls of the bay. That concentrated all of the power into one violent burst. That's why the water climbed so high. What happened in Lituya Bay wasn't just bigger than a normal tsunami. It was an entirely different kind of event. That's why geologists eventually stopped trying to describe it with the old term. They needed a new one, mega tsunami, because nothing about this disaster fit the rules people thought they understood. In just a few seconds, a peaceful bay became one of the most powerful natural events ever witnessed. And for everyone still inside that bay, the real nightmare had only just begun. The more scientists studied what happened at Lituya Bay, the stranger it became. At first, people assumed the earthquake had created the wave. That seemed like the obvious answer. But the numbers didn't make sense. A magnitude 7.8 earthquake is powerful, no doubt about it. But earthquakes like this usually don't create waves anywhere close to 1,720 feet. In fact, the Fairweather Fault mostly moves sideways, not up and down. And that's important because a typical tsunami happens when the seafloor is lifted vertically, pushing a huge volume of water upward. That never happened here. The earthquake only set the stage. The real force came from the mountain collapsing into the bay. To figure out exactly what happened, the U.S. Geological Survey sent geologist Don Miller to investigate. He spent weeks walking the shoreline, measuring the damage, mapping where the trees had disappeared, and comparing every measurement with eyewitness accounts. What he found changed the way scientists looked at these events. Running across the mountainside was a perfectly clear boundary. Below it, everything had been stripped away. Trees, soil, and vegetation were simply gone. Above it, the forest was still standing. That line became known as the trim line. It marked the highest point the water had reached before falling back into the bay. It wasn't a guess or an estimate. It was physical evidence, still visible on the mountains decades later. Even today, you can fly over Lituya Bay and see that line with your own eyes. For scientists, the trim line became one of the strongest pieces of evidence ever recorded for this kind of disaster. Every major survey since 1958 has confirmed the original measurements. The numbers haven't changed. And that led to an even bigger realization. What happened at Lituya Bay didn't fit the definition of a normal tsunami. The physics were different. The source was different. Even the way the water moved was different. So researchers gave it a new name: mega tsunami. It wasn't just a bigger tsunami. It was a completely different kind of event, created when an enormous mass of rock crashed into a confined body of water with incredible force. That single discovery changed geology forever. And it also raised a much more unsettling question. If it happened once, could it happen again? When the wave finally rushed down the bay, 3 fishing boats were directly in its path. Each crew experienced the same disaster, but each story ended differently. The first boat belonged to Howard Ulrich. As soon as the earthquake hit, he ran onto the deck. Looking toward the far end of the bay, he saw something he would never forget. Part of the mountain had collapsed, and a massive wall of water was racing straight toward him. There wasn't enough time to think. He started the engine, cut the anchor line, and pointed the bow directly at the wave. It was the only chance he had. By the time the wave reached him, it had already traveled several miles, but it was still enormous. His boat climbed the face of the wave, reached the top, then dropped down the other side. Somehow, the boat stayed together. When everything settled, Howard was still alive. The shoreline around him wasn't. Entire sections of forest had disappeared, leaving nothing but bare rock where giant trees had stood only minutes before. The second boat belonged to Bill Swanson. His situation was even worse. The wave caught his boat from behind before he could turn around. Instead of driving over it, the entire boat was lifted into the air. The wave carried it over a natural gravel barrier at the entrance to the bay and dropped it into the open ocean on the other side. Think about that for a second. A full-sized fishing boat was carried over land by nothing but water. His boat was badly damaged and eventually sank. But Bill and his wife managed to escape in a small skiff. A passing vessel rescued them before sunrise. They survived. The third boat was Sunmore. It was anchored farther inside the bay, closer to where the mountain collapsed. Howard Ulrich later remembered seeing its mast light moving across the water just before the wave arrived. Then, it was gone. No distress call. No wreckage. No floating debris. Search crews spent days looking across the bay and the nearby coastline. Aircraft searched mile after mile of open water. They found nothing. Not a single confirmed piece of the boat was ever recovered. Of the 3 boats that entered Lituya Bay that night, 2 eventually made it home. The Sunmore disappeared completely. Stories can be questioned. Memories can fade. Even eyewitnesses can remember things differently after a traumatic event. But Lituya Bay has something that doesn't rely on memory. It has proof. When scientists arrived after the disaster, they found a sharp line running across both sides of the bay. It stretched for miles along the mountains, almost like someone had drawn it with a ruler. Below that line, everything was gone. The forest had been completely erased. Trees that had stood there for nearly 2 centuries were ripped out by the roots. The soil disappeared. Even large patches of vegetation were stripped away, exposing nothing but solid granite. Above that line, the forest was untouched. It looked like 2 completely different mountains. Scientists called this boundary the trim line. It marks the highest point the water reached before falling back into the bay. More importantly, it shows exactly how far the force of the water was able to reach. This wasn't someone's opinion. It wasn't an estimate. It was physical evidence left behind by the disaster itself. Don Miller measured that trim line only weeks after the event. Since then, other research teams have returned again and again. They surveyed the bay in different years, using better equipment each time. The result has always been the same. The measurements match. Even after all these years, the evidence hasn't changed. If you fly over Lituya Bay today, You can still see that line cutting across the mountainside. The older forest above it is dark and dense. The younger trees below it are lighter because they all started growing after the disaster. It's like the mountain still carries a scar. More than 68 years later, it's still there. That's one reason this event is so important to scientists. Most natural disasters leave behind damaged buildings or written records. This one left an unmistakable mark on the landscape itself. The trim line became the benchmark for studying megatsunamis around the world. Any scientific model trying to explain these waves has to match what happened at Lituya Bay. If it can't explain that line on the mountain, it's incomplete. Nature doesn't keep written records, but sometimes it leaves behind something even more convincing. And in Lituya Bay, that silent line across the mountain is still telling the same story it did in 1958. For a long time, people thought Lituya Bay was a one-of-a-kind event. Something so unusual that it would probably never happen again. But the more scientists looked into it, the more they realized that wasn't true. Lituya wasn't an exception. It was the first event that was carefully measured and documented. Just 5 years later, another disaster shocked the world. In 1963, a massive section of a mountain collapsed into the Vajont Reservoir in northern Italy. The impact sent an enormous wall of water over the top of the dam. The dam itself stayed standing, but the waves swept through villages below and killed nearly 2,000 people in just a few minutes. The cause was different, but the physics were almost the same. A huge mass of rock fell into a confined body of water, and the displaced water became unbelievably destructive. Years later, similar events were recorded again. In Greenland, a mountainside collapsed into a fjord in 2017, creating a giant wave that destroyed part of a coastal settlement and claimed several lives. In Alaska, another rockslide hit Ton Fjord in 2015. Thankfully, no one was nearby, but the water still climbed roughly 600 feet up the surrounding mountains, leaving behind another visible trim line. Even Chile has experienced the same kind of event in its steep glacial fjords. Different countries, different years, the same basic pattern. A weakened mountainside, a sudden collapse, a narrow body of water with nowhere for the energy to escape. Today, one place has scientists paying especially close attention. It's called Barry Arm, also in Alaska. The landscape there looks remarkably similar to Lituya Bay. The cliffs are steep. The glacier that once supported the mountainside has been retreating, and satellite data shows that part of the slope is slowly moving. No one knows exactly when or even if it will fail. But experts agree on one thing. If a collapse of that size happens, it could generate another megatsunami. That's why Barry Arm is now under constant monitoring. The lesson from Lituya isn't just about one night in 1958. It's about understanding a process that can happen anywhere the same conditions exist. Lituya showed the world what was possible. Everything we've learned since then has shown that it wasn't the last time nature used that same formula. You might think a disaster like Lituya Bay belongs in the history books, something incredible that happened once and could never happen again. The truth is a lot less comforting. Scientists believe the same conditions still exist today. One place they watch very closely is Barry Arm, a remote fjord in southern Alaska. At first glance, it doesn't look unusual. It's quiet, beautiful, surrounded by steep mountains and deep water. But that's exactly what Lituya Bay looked like before everything changed. Over thousands of years, a massive glacier supported the mountains around Barry Arm like a giant brace. As the climate warmed, that glacier began to melt and retreat. With the ice pulling back, the mountains lost part of the support that had been holding them in place. Now, one section of the cliff is slowly moving. Not feet every day, not even inches every month, just enough for satellites to detect it. That might not sound alarming, but to geologists, it's a warning sign they take very seriously. That's why the Alaska Department of Natural Resources continues to monitor the area using satellite technology. They track tiny movements in the mountainside, looking for any change that could signal a larger collapse. No one knows exactly what will happen. The slope could remain stable for decades, or it could fail much sooner. That's the difficult part about geology. It doesn't follow a schedule. If a massive section of that mountain were to collapse into the fjord, scientists believe it could generate another megatsunami, possibly on the same scale as Lituya Bay. And that leads to another uncomfortable reality. Some communities nearby would have very little time to react. In places like Whittier, experts estimate a large wave could arrive in as little as 20 to 30 minutes after a collapse. Even more concerning, there isn't a practical evacuation plan for a wave of that size. The mountains are steep, the waterways are narrow, and when minutes are all you have, there may not be anywhere safe to go. That's what makes this story feel so relevant today. Lituya Bay wasn't just a remarkable event from 1958. It became a warning, a reminder that nature is still shaping these landscapes, one small movement at a time. Most of those changes happen so slowly that we never notice them, until one day, everything changes in a matter of seconds. More than 6 decades have passed since that night in Lituya Bay. The boats are gone. The people who lived through it are almost all gone too. But the mountain is still there, and so is the trim line. If you fly over the bay today, you'll still see that sharp line stretching across the mountainsides. Above it, an old forest that survived. Below it, younger trees that only began growing after the disaster. It's like nature kept the evidence exactly where it happened. No monument could tell the story more clearly. What stays with me isn't just how big the wave was, it's the fact that the landscape never forgot. For scientists, that line is more than a scar. It's proof of what happened. It's a reminder that when the right conditions come together, nature is capable of something almost impossible to imagine. And those conditions didn't disappear in 1958. Steep fjords still exist. Unstable mountains still exist. Glaciers are still retreating. Around the world, there are places where the same process is unfolding, slowly and quietly. Most of the time, nothing happens. The mountains move by inches. The rock keeps holding together. Until one day, it doesn't. That's why Lituya Bay isn't just a story about the past. It's a warning for the future. A megatsunami isn't something that belongs only in history books. Scientists know it can happen again. The only thing they don't know is when or where. Nature doesn't make appointments. It doesn't give second chances. It simply follows its own timeline. Maybe that's the biggest lesson from Lituya Bay. Some of the most powerful forces on Earth don't announce themselves. They build in silence, sometimes for centuries, before changing everything in a matter of seconds. So, maybe the real question was never whether another megatsunami will happen. The real question is, where will it happen next? And who will be there when it does?